So this is my pathfinding um, monster maze assignment. Um, have a couple different AI to show off. First here, my one that I created that runs off the idea of making it through a maze by holding your hand on the right wall. So he just simply gets to the wall immediately and will just walk along it, and anytime he finds something in his path, he'll just turn left, and whenever he's able to, just turn right. He'll just always do that until he reaches the goal.
This guy's got dick cheese. You got dick cheese, dude. What the fuck are you doing? Alright, bye.
As you can see, it's not always the most efficient of
This guy's got
paths, as some of the other AI
Oh my
have
god.
actually already made it to the goal.
I'm losing. I know it. It's okay. I got you.
The next AI is simply Unity's nav mesh. It is obviously very good. Um, Updates dynamically and can find a path as long as there is a path through anything for sure. So he will very quickly make it to the end of the stage. So you can see he's already made it to the end. Next we have our Dijkstra's algorithm. This one is based off of breadth first, but instead has a weight value that it can be placed onto the nodes to decide how much like a hassle it would be to travel through that area, whether it'd be slower or the AI just doesn't want to. Uh, in this test, I don't show off that feature, but it does. He will avoid any node that is of higher cost than others. The next AI is A star, which works similarly to Dijkstra's, where it has a weight that can be placed on the nodes, but also will travel to the node that is the closest to the goal. The heuristic I used just simply checked the distance from goal, so he will move oftentimes in a diagonal line to get to the goal because obviously moving diagonally is the closest way. But because he can't travel diagonally, he'll end up just kind of going left, right, left, right, left, right to get closer to the goal, as you'll see when he gets to the end. So next will be breadth first. This just simply checks all of the closest nodes to itself in an outward pattern and will try and find its way to the goal in the shortest distance, pretty much. It doesn't have any weight that can be used to influence its decisions, nor does it check which nodes are actually moving closer towards the goal. It just will check in a big outward pattern. And finally, we have our object avoidance AI. He will basically face towards the goal immediately and just try and walk at it. And if anything gets in his way, he will find the dot product of the object compared to himself and avoid it. So as you see, this object was on his left, so he turns right. Periodically, he will try and walk towards the goal again, and then if something's in his way, he'll avoid again. So yeah, he's heading towards the goal, and boom, wall. So he avoids, avoids, avoids. You notice the two walls he ran to originally were on his left. This wall here will pop up, and it's on his right. So he'll go to the left, and he'll head on to the goal. So those are the AIs that I have for this class.